Hi, everyone. Thank you for joining us today. This is Caroline Griffin. I am Riot's Event and Operations Manager. We're very excited to have Greenstream Technologies here with us today. We have Jim Gray, Karen Lindquist, and also a very special guest, Terry Yates with the Town of Cary here with us. Before we get started, just a couple quick ground rules. If you have any questions, please do put those in either the Q&A box or the chat box, and we will make sure that your questions are answered. This session will be recorded, so if you need to leave early, no worries. You will be able to view the entire recording on Riot's YouTube channel. And the participant list is hidden, so do not worry. You are not the only person here. You just can't see the other participants to protect their privacy. We do get that question pretty often. Without further ado, I would like to introduce Karen and Jim, and thank you for being here with us today.
Well, hello, good afternoon, ladies and gentlemen. I'm Karen Lindquist, and I'm co-founder of Greenstream, and we are delighted that you joined us to learn about a project we've been working really hard on these past months with our partners, Data Without Borders. Greenstream is an environmental IoT startup based in Wake Forest, North Carolina. And by the way, welcome to our workshop here at the Wireless Research Center, a little bit messy behind me. We monitor and report localized flooding in real time through our sensor network and our communication and our cloud services. Our approach has won awards from MIT Solve and NC Tech, and we've also been supported immensely by Riot and NC IDEA and a Boston-based organization called Leading Cities. My partner, Jim Gray, is the technology architect of our end-to-end solution, and I run the business side. Real-time, localized data about rain from the sky and flooding on the ground allows our customers to respond proactively during flood events and to make more precise predictions about future flooding based on ground truth data. Here's our local region. We are in the Raleigh region in North Carolina, and like other regions, it's made up of individual cities and towns and counties. And many of them are on their smart city journey, some further along than others. They're finding ways to gather data, and they're using that data to provide better services for their citizens. And some of those are putting sensors in place to increase safety, to increase convenience, or internally to reduce costs or to allocate resources. Now, cities tend to think of their own jurisdictions, or they think in terms of their own jurisdictions, and they are largely concerned with data and events within their own borders. So they have their own systems, their own vendors, their own historic ways of doing things. But cities aren't islands. There are certain phenomena a city has to manage that don't care at all about the city's borders. Think about things like traffic or crime or pollution or weather events that flow across borders. A smart city can't easily address the situation on its own. To be really effective, it needs collaboration with its neighbors and with its county and with its counterparts at the state level. A really good example of this is the type of data that we produce for our customers, rainfall and flooding data. So if there is a heavy downpour in the town of Cary, for example, and we're going to hear from Terry Yates, he's the Smart City Director of the town of Cary a little bit later, but if there's a heavy downpour in Cary and Crabtree Creek up here starts to flood in Cary, it flows down toward Raleigh. And for those of you who live in the area, it crosses Route 70 here. It floods Crabtree Valley Mall, goes on to Six Forks and Old Wake Forest Road. So the need for these neighboring municipalities to collaborate is growing because flooding's getting worse, and there are more people and more property at risk every year with increased flooding and increased development. States and municipalities have a shared interest in improving their flood monitoring, not just for themselves, but for the rest of their region. So a microburst and street flooding impacting one community is going to have impacts on its neighbors downstream, downhill, downwind. And trying to share data when everybody has a different system, that slows down response. And the following statement is typical of what we hear from our customers. They say, like, our emergency operations people are calling each other in other departments and in other towns, and they're trying to describe what they see on their computer screen or what they see out their windows. And it's really confusing, and it slows their response. If you are, for example, much further downstream in a city like Wilson, North Carolina, if you work in emergency management or if you work in infrastructure, you'd want to know if this is coming at you from upstream. And water really doesn't just flow across municipal boundaries. It flows across counties and it flows across states. That water wants to go where it wants to go, and water data really truly is without borders. So what's even smarter than a smart city? A smart region. And to be a smart region, the communities within the region need a mechanism for collaboration and data sharing without having to make too many changes to their investment in their internal systems. So we started having these conversations about sharing with North Carolina Emergency Management, with the city of Wilson, and with the town of Cary. We were in the Riot Accelerator program at the time, and we started talking with Tom Snyder about organizing some type of data sharing. And one of Riot's mandates is to facilitate smart city solutions and regional collaboration, and Cary and Wilson are closely involved with Riot and their efforts. So Sarah Globa of Riot, she took the lead in organizing a committee to build a regional agreement for sharing data, starting with our stormwater use case as a driver, since all local governments in North Carolina are dealing with flood challenges. And these towns that are involved are starting to acquire their own rainfall and flood sensors to get their first localized data. Town of Cary is a key influencer for smart city technology, not just regionally, but also on a national level. And they're a driving force in this effort. They were since the beginning, and they continue to be. Cary took the lead in attracting other local governments as well into the project, as well as some of the big tech companies you see here at the bottom of the left-hand panel. And they are taking the lead in creating open data for their neighbors to consume. And from Greenstream, from our side, we contributed our technical architecture to the effort, and you're going to hear about that in a minute. But since starting last fall, Riot, Cary, and Greenstream met every week to build out the concept and the documentation. And by December, we began to meet as a larger group with the other partners, including Wilson, Raleigh, Wake County, North Carolina Emergency Management, and Cisco, and Oracle, and SAS. The artifacts we produced here are shown in the second column, okay? The project charter sets forth the goals for regional data sharing, and governments sign on to it to signal their intention to publish their open data for their neighbors using a common protocol. And they consume data from their neighbors using that same protocol, with the aim of facilitating collaboration on those problems that tend to flow across borders. We've also created a technical architecture. Some cities with resources already have sophisticated internal architectures, and this document may provide some ideas about how to make their data more shareable with their neighbors. But many smaller cities and towns are new to IoT and they're new to smart city solutions, so the document provides them a foundation and best practices on which they can build their systems. And it also advises what the cities should look for in IoT vendors to be sure they can produce and share useful data. The data rights agreement states that each community owns its own data, and they can freely use another community's data, but they can't sell it or share it on to third parties. And they agree to produce the most accurate data they can, but they also agree not to sue each other in case of any mistakes or omissions. The idea is to create appendices with details on different use cases for data without borders. And the first use case, providing advice around monitoring and sharing stormwater data, is Appendix A, and that one is more or less built out. We still have more use cases to build on, and hopefully the group will be able to help us a little bit today to brainstorm some of those. And we are still on our journey. We're more at the beginning of our journey than at the end, but the initial outcomes so far are that some communities have taken their first steps toward data sharing using the protocol. Town of Cary has submitted the project for an award, and we all won together as a community, thank you, Town of Cary, in the IDC 2020 Smart City Water category. Our local Council of Governments has agreed to host the documentation, promote the approach within the region and to other regions and beyond. The whole purpose beyond developing the approach and documenting it is to share. So that's why we share, and this is what we are doing so far. My co-founder and partner, Jim Gray, he's the CEO of Greenstream. He is going to share with you a little bit more about the technical architecture for data sharing. Jim,
Okay.
over to you.
Great. Great. Well, thanks, Karen. Again, my name is Jim Gray, and I'm going to be talking a bit about the technical architecture and the data sharing effort around this project. As Karen mentioned, the working committee has been put a lot of effort into developing all these artifacts and coordinating amongst the players to be able to come up with a solution that really can work at a regional level. And so we're going to talk a little bit about the technical architecture deliverable and specifically the data sharing portion of that. So one of the things that we really wanted to try to do up front early on with respect to the technical approach to this, to a regional solution is make it very straightforward to implement and something that's not invasive and non-burdensome and also cost effective. We didn't want to go into this and have something that where the cities would have to either start over from scratch or abandon what they're already doing and rework it. We wanted an approach that really could build on what they had already begun to do with respect to smart city solutions and just not really put too much of a heavy burden on them to be able to try to participate. So given that these initiatives, that the region, the municipalities have efforts underway, we decided to take a decentralized approach to this. So that way the municipalities can continue to build on their existing projects and continue their efforts, and we're not coming in and asking for something that's too disruptive. And so what we really focused on was data sharing, because that is kind of the key to this, is being able to share this data that crosses the borders between the municipalities. And for municipalities with efforts underway, this should hopefully be just a small augmentation to what you're doing. But for cities that are in the early stages, we also did put together a logical architecture, which we hope acts as a blueprint for them to be able to build out a more robust smart city solution. And we try to do that language in the documentation. So not only did it act as a blueprint, as a technical document, but also something that they could use for a basis for RFIs or RFPs if they were to put out solicitations in the future. And we're hoping that the approach also kind of helps to reduce the implementation costs. Again, not being too burdensome on the participants. So it looks a little like this. This is our diagram. You can see all the participants, and in the center is North Carolina Emergency Management and specifically the Feynman system, which they manage and maintain. So in this, you can see that all the players can talk to each other. So what does that really equate to, or what does it really turn into? From a systems perspective, it really just turns into like a virtual community of peers. So these peers can, are participating. The idea is they're engaging in tasks that really are something that they can accomplish that's beyond something that they can do individually. Being able to pull this regional data in helps them to make them more efficient with the smart city solutions they're implementing, but also possibly offer solutions that or services that they just weren't possible before. So it kind of does look like a peer-to-peer network. And with that, the peers, we kind of mandated that the peers are all equally privileged. So no one's taking on more responsibility than the others. They're kind of equally acting the same. All the peers can be suppliers and consumers of data, and they all have the option to opt in and out. And the only exception to this would be the Feynman system for NCEM. They are the central node. So all the peers we hope, agree to feed that data into the Feynman system. Not only does it help regionally, but now this data is bubbling up to the state level, and it's helping to grow the NCM sensor network as well. So as part of that, we've defined some what we call good neighbor guidelines around that. Is that the peers agree to acquire their sensors and to manage their own networks. So for, as far as the whole regional system goes, each municipality looks a little bit like a black box. What sensors you put in and how you go about that acquisition and how you go about the back-end build-out really is up to the cities. And again, trying not to be too invasive on what they're already doing and undertaking, but we're asking that if you participate, that you share that data. That really can come in the form of an open data portal or some publicly published site where the other peers can pull the data. We are asking, as part of the documentation, we did set the guidelines that there really is no central repository, again, with the exception being the North Carolina Emergency Management, and that the peers really publish data that's related to them and not necessarily the other peers. In essence, they're a repository for their data, but not the other peers. So we don't want a situation where the Holly Springs can expect to go to Wilson and get everybody's data. They can only get Wilson's data, and you can only get Cary's data. And again, the exception to that would be NCM, given that they're the central node in this peer-to-peer network. So that allows, so if worst case, you can go to NCM and get a consolidated set of data, but we're trying to avoid the idea of network flooding. We don't want to be jamming up someone's system where everybody's going to them and expecting them to be the central repository. And then also, we're all agreeing to a common data protocol. And that's part of the architectural document. We have a data view, and with that, and this is what we're going to talk about next, we've outlined how can we capture that data, what's a common way to hold that data and store it, and then the common protocol for publishing the data. So with that, the documentation outlines the idea that everything will be published, all the data will be published in a JSON format and be accessed over RESTless APIs. And the idea is all the players in the community can subscribe to these services as they need to be able to pull whatever data they need. The participants really decide on what data they share or how much data or what types of data. And of course, they can rescind at any time. But if they do agree to share, we're asking that they publish some key pieces of information, which is information about their devices, information about the sites, and event data. And we're going to define those here next. So with any type of data sharing, we're all agreeing to communicate, to share, and so with that, we need a common language. A set of terms that we all understand and, with respect to a common protocol. So with that, what we've defined is events. And what we mean by an event is just this is a condition at a point in time and location. So an example of event would be water level or temperature or air temperature or humidity. Those are kind of events. And they are really kind of the central piece of data throughout this. At the heart of it, this is the data we really truly want to be sharing amongst the participants, is the event data that they're capturing. And we want to be able to do that in real time or as quickly or close to real time as we can, because this event data not only it's key data, but it's also timely data. And we want to be able to respond to these events as they come across as quickly as we can. Sensors. Sensors are that apparatus that measures the events. those little devices that are attached to our devices, which we're going to talk about, and they measure those environmental data or parameters. A device is an apparatus that not only contains the sensors. Sensors are attached to those devices, but they also transmit event data back to our back-end systems for processing. And those messages also get eventually published through the Open Data Portal. And messages are really a package of data that contain events. So a device can send a message that contains maybe one event, but it could send multiple events. For example, one device could send a single message that would contain water level, temperature, battery voltage, battery current, and signal strength. So those messages eventually get unpacked and broken apart into individual events on the back end. Another key element to this language is the site, and it is a geolocation where one or more devices are hosted. When we have these events occur, we need to know where they are, and the sites give us that information. So we want to try to capture not only the latitude and longitude, but also information such as address. It's great that we can put latitude and longitude in, but addresses really are something we could also pop into a map. And for example, our field service guys can use that to be able to locate those devices. And it gives us a little bit of context with respect to the location. Thresholds. So we have devices and sensors in the field, and they're sending messages, but we want to be able to act on that data as it comes in. So some of our sensors have the capability to set thresholds. For example, water level is a good example where Cary has done this, where they've set multiple thresholds. So the idea is that when the creek is dry, well, we're not that concerned. But when it gets, above the culvert or starts filling the culvert, maybe we want to keep an eye on this. And when it gets above the top of the culvert, maybe we want to start taking some action because maybe we have a potential problem here. Well, those thresholds define what are those levels, and then it gives the capability for the system on the back end to take action based on those thresholds. And those are set on a per site basis. And finally, we have tags. So the idea behind the tags is to provide some additional dimensions to the entities and specifically to the events. So for example, it's great that when an event occurs, we can say the water level was 3 foot deep on Monday, July the 10th at 2:30 p.m. At site Park Street. But sometimes you like to be able to pull that data in different ways. So think, for example, as Karen showed on the previous example of Crabtree Creek, wouldn't it be great if I could come in and say, give me all the sensor data on Crabtree Creek? Well, that's where these tags come in. They add that extra capability to do queries and pull groups of event data and put it in a context that maybe makes sense for the outside players. So for events, I'm kind of expanding on this a little more. One of the things we were shooting for is base set of data for an event. We want to make sure that what gets published is sort of these key elements with respect to event. So we want to know who sent the event, which device, right? What was the event? What type was it? Was it rain? Was it temperature? Was it stage? What is that type of event? When did it occur? What's the date and time did it occur? And where did it occur? So that's back to our sites and indirectly to our devices. So with that base set of data, we've got that. We know the location, we know the time it occurred, we know the type of event that occurred. And optionally, we have these tags associated with them. So we can do just like I mentioned before. Give me all the water levels on Walnut Creek at 7:20 at 5 p.m. So that way we can pull that data as a group and have a nice correlation between them. Okay. So with all that language and with all that data coming in, one of the first things that any participant has to do is to be able to capture that data and store it. They got to hold it. So what we've done is put together an entity relationship model around these items or these common terms. to show not only what they are in the details, their parameters, but also their relationships. And this is a high-level morphological entity diagram. So we're not mandating that you have to do it in a specific type of database, but this is really acting more as a guideline to be able to structure your data when you go to set up whatever type of data storage product to use. So again, at the heart, we have our events. And of course, these events are associated with a given site. And you can see our sites can have multiple tags associated with them. And also our sites have devices, and we could have more than one device at a given site. And that device is also made up of one or more sensors. So that kind of helps tie together the relationship between those common entities that we kind of outlined during with the common language. So once we've got the data and once we've stored it, we want to publish it. So how are we going to do that? We mentioned earlier we want to do data as a JSON format and do it as RESTful APIs. Well, we got to define those endpoint APIs. And there's some supporting data that comes with that. Really, the APIs need to be able to support querying the data in multiple ways and across multiple dimensions. And at the heart of it, at minimum, we want that event data, but it would be nice to get the device and site data as well as part of the API set. And we were trying to shoot for the idea of the APIs are following a common protocol so it can reduce the overhead on the participants. That way we don't have the situation of I have to go have a different protocol and a different format for one participant and a second one for a second and a third, and now we've got to somehow kind of correlate all this and do a lot of parsing to be able to align the data. We're hoping that by following this protocol, in this approach, then we ease the burden on the participants at the regional level. So it's not only building out the APIs, and the three core ones are being able to get the events, get information about the sites, get information about those devices that are at the sites, but we need supporting documentation. So you need to be able to publish. What is the URL for that RESTful API? What type is it? Is it a GET? Is it a push? Is it a post? What are the query parameters? And that is a big piece of this. What kind of parameters can I use to query this data? What does the result set look like? What does the message format look like? What am I getting back? And then, of course, any response codes. Was the query successful? Did I have a failure? And if I did, what are those response codes telling me? That did I misformat my query parameters? Or is there something wrong with the URL or whatever? It's basically error codes. And if the participants deem the data to be public, then we're asking that they publish it to some form of open data portal so that it's available to all the rest of the peers. So the first item we want to do is the get events. And that event API, what we try to do is define a base URL. And again, these are guidelines. We're not mandating that it has to be this way. We realize there's challenges around being able to get the data, the APIs in a given URL format, but these are just sort of set out as something to follow. But for the events, what we've defined is for query parameters, and this is kind of the key piece or key component of any API, is how do I pull that data? So we want to be able to define what type of event. We want to be able to say, is it water level? Is it air? Is it air quality? Is it temperature? So we can pull those events. We want to be able to ask for the site. Can we go to a specific site and say, give me that event data for this given location? For Byram Street in Cary. We want to be able to put a time frame around it. So if we want to pull groups of data, we want to be able to define when do we want to start? When do we want to end? So that we can pull. Can we pull a week or a day or a few days? We had a big rain event, so it would be great to be able to frame up that query around those dates. But also a limit. Where the limit comes in, you could come in and do combinations of start and end and limit. But more specifically, limits, a limit field gives you the capability to say, give me the last 10. So it will go and pull the last 10 records. This really comes in handy when you're in a situation where you're occasionally going and pulling the data. you can say, if I'm going out every hour and you know that I get a message every 6 minutes, you can say, hey, just give me the last 10, and I know I get the hour's worth of data. And additionally, we have these tags so that we can pull event data around additional parameters. So wouldn't it be kind of cool if Raleigh could come in and say, Raleigh knows that they're impacted by Crabtree Creek, but if they could go to Cary and say, hey, give me everything that you got on water level in Crabtree Creek, then they've got the data that they need to do the analysis or determine, do they have a flood event that's literally coming toward them, right? And of course, we have our response codes on that. The 200 says we've had a successful response, or the 500 says we've had an error. And the result set would look something like this. We'd have our ID, we'd have our site ID, the type of event, what was the value for the event, and the timestamp. A couple things to note from the timestamp perspective. We've defined that our timestamps to be in the epoch format or Unix time. So that gives us a common time frame across all the players. So we're kind of eliminating the whole issue of time zones by going with that. The other interesting thing that came out of this was site IDs. There was a lot of discussion of how do we tag a site? How do we give it a unique ID? In the past, North Carolina Emergency Management was using a combination site ID, sensor ID for their systems. But they came up with the idea of, instead of us having a central repository where someone has to get assigned a site ID, why don't we do it based on lat and long? So we've standardized on the notion that site IDs really are lat and long. So what you're seeing here is the first 2 digits of the lat, the next 6 digits of the latitude, then the first 2 digits of the long, and the next 6 digits of the longitude. That way we end up with unique IDs. We don't have to have a central repository, and everybody can assign their IDs without having to create this overhead of site ID generation and management. For site data, what we're looking for, when we want to query for sites, it's great that we pull this event data, but it'd be nice to know a little bit about the site. Where is that site? What are the parameters that are related to it? And so that's what the site API is doing. We don't really have any query parameters. The idea is you just go ask for it, and it comes back and says, here's all our sites. And then hopefully from there, the participants can use that data to be able to do queries or for event data that are based on sites and site IDs. So the result could look something like this. Of course, there's a unique ID, and there's our lat-long combination for the ID, but we could put a name, description. Here's our address for the site. So it's something that's textual, it's human readable, something we could pop into a map and give us a sort of a context of where that location is. But we also include the lat and long, so we could use those as well. We've got our tags. So in this case, this one's tagged as United States, North Carolina, Wilson, Hominy Swamp. So if I wanted to come in and do query around those tags, I could say, just give me data on Hominy Swamp, and all that data would come back as part of my event query. Or we could filter it by region, and that's what those tags are doing there. But also we've defined some parameters around that site. In this case, we've got a site that's got a water level sensor or a stage sensor, and we talked earlier about those thresholds. Well, here's where those thresholds are set, and they're done at the site level, so that because it's all about what is that site, what are the parameters for that site, not necessarily what the device that's there. And then, of course, the status and our timestamp for when that device was created, the record was created. The third item is devices themselves. Very similar to sites, you can just do a query with no parameters, and you'll get back all the devices. But you could specify a device ID to get information about a specific device. And we should add in there, I just realized I should have put the site ID, so we can query on the site and say, hey, for this given site, can you tell me what type of devices are there? Where that comes in handy is, sure, we have the name and description, but what's more important is this gives me back an inventory of that device. What sensors are attached and what type of sensors? is there any additional parameters like an offset for the stage that are set for that device? So then I have an idea of what can I pull for, what can I query from for that device and indirectly from that given site. And you'll see that at the bottom that the sites are associated with that. And then optionally, I put in a version number on this one. We don't necessarily need that, but that's really to define if we have a firmware update to that device or what current version is it running, so we know what version our app is running on that device. So with that, we've got an extra chart there. That kind of concludes my presentation with respect to data sharing. And I'm going to turn it back over to Karen.
Thank you, Jim. I actually learned something by listening. And Terry, thank you so much for joining us today. We really appreciate that you're coming in to tell your experience of working with this flood data and your steps so far on sharing. We'd like to hear from you.
Good afternoon, everybody. Karen, I just want to thank you and Jim and Riot, just for allowing me to be on this today, and everyone that's participating. And I also want to kind of, before we get started, thank all of our regional partners, not only municipal, but state, county, and our corporate partners, because we have been working on this effort for about a year now, and to see the level of commitment that's still involved in it, and that we're all see this vision that's really coming, it's really being implemented is really exciting, and to stay with that effort has just been amazing. And so I just want to thank them, all the municipalities, City of Raleigh and Wake County and North Carolina Emergency Management and Cisco and SAS and all of them. So, yeah, and so as far as our carry journey on this, we've had a stormwater, adaptive stormwater program for several years now, and it's really made up of our citizens, businesses, and staff really looking at ways that we can improve our stormwater response environment, helping our citizens to mitigate those types of issues. And really, it's that partnership, as well as our Smart City program that has been in place almost 5 years now. And I always like to talk about how that my position did not exist 5 years ago. So when we talk about automation, how automation's getting rid of jobs and all of this stuff, my position didn't exist. And because of this new automation technology, it was created. And so I think that's really a good success story around, what we're doing. And, this is as Jim and Karen were mentioning, stormwater is an area that we can, the technology piece, it's something that is not that controversial, where we can share data. And it's something that it's been a awesome effort putting in sensors and all of that. But from a carry standpoint, our big message, and for folks that are on this may have heard this before, but it's about for us our platform strategy, which entails really bringing all of these IoT devices and IoT systems and databases into the platform architecture that our users use every day. And when I say our platform architecture, I mean we use Esri for our GIS services. I always refer to it as our visualization platform because that's where you see the real-time status of sensors and how it correlates with our other sensors out in the field. Salesforce, which is our CRM platform, which does our work order management. So when we get those calls in, we want to be able to dispatch someone out to address that issue or just monitor the issue. SAS, which is our analytics platform, we do a lot of all types of analytics with them, and so bringing this in is just a natural fit. And then Office 365 Microsoft, which is kind of a key point where we bring in the sensor data and all of that. I can't go without saying that, having using those platforms really helps to have your user buy-in at an agency, because those are the things they use every day. And the more we can utilize the platforms that they use every day, the more buy-in we have from our user community. When we talk about going out and getting another dashboard or another solution, buy-in is difficult. You've got training involved. You got to get people on board with, hey, this is a good, a solution. And when you already are injecting it in the platforms you use, all of that's taken care of. The security pieces are taken care of. So, that's been one of our big strategies, and as far as our implementation, that I think is unique with Carey. And the other thing I'll say, that as part of this journey, it was real important, and Jim touched on this, is that JSON format. So we manipulate the JSON format as early as we can when it is injected into our platforms. And why we do that is because once you get it in that format that you want it in, it makes it so much easier to ingest in all of our other systems and platforms. You don't have to do that manipulation in every single platform. It's already done. So as the data's flowing, it flows into Esri the same way it flows into Salesforce, the same way it flows into SAS. And I think that's huge. And then, we pass it on to our regional partners from there. As far as the regional effort, I think, we're making such great strides, and we're creating, I always refer to this, and people may laugh at me, but agencies, when they're trying to communicate with their different systems, it's almost like in the Bible, how you have the Tower of Babel, and you've got all these different agencies, and they're all speaking different languages. And so what we're doing here is we're just getting all together, and we're saying, hey, we're all going to speak the same language so that we can communicate and we can share data. And it's cool that you're maybe this way, and you're this other agency, you're that way, and you can have all the pieces and components and the different cultures, but when we talk to each other, we're going to speak the same language. And I think that is a simple way to kind of describe what this has entailed. And really, when you do something like that, it helps. Oftentimes, there's contention about, a master system that houses the data and controls everything. And I think this really is a model that takes that concern out of it. You can still have your own systems and manage your own systems, but we can share our data with each other and really gain the benefits of that. And then, lastly, from a measure of success, one of the things around this regional program is that we measured success of if 2 agencies that are involved can share our data with each other, then that is a success. Because it's important as you're going through this journey to make sure that the goal is achievable. And oftentimes when you put too many parameters around it and too many things that you're trying to achieve, it makes it very difficult to obtain a goal. And it also makes it where folks start kind of, other priorities come up and they really can't focus on that. So, I'll leave it at that. And like I said, again, I appreciate Riot and Greenstream for allowing me to speak a little on this topics today.
Thanks, Terry. Thank you very much. And so, yeah, I should have advanced the slide. So, of course, sharing is caring, and data sharing is caring about your region and your neighbors. That's it from us. We were wondering if anybody out there in the audience had questions, and if not, we have a question for you. I'm looking at the chat to see if any questions are coming in. Yeah, Hans. Caroline, is it possible for Hans to speak?
He is on mute. Let me see if I can get him off mute. And you should be able to speak now if you'd like. We'll read his question out loud for the group. Hans is working in a company, iotics.com, and if he could get in contact with someone in this project to share his experience with other cities they have worked on, who would be the right person to talk to, Karen?
Okay. Who would be the right person to talk to if you want to share your experience with other cities? Caroline, that would probably be Riot as the central one. That was one of the questions we came up with. If somebody wants to talk to us, who should they talk to?
Thanks so much. Yeah, Hans, if you want to reach out to me at caroline@riot.org or anyone on our team, we'd be happy to point you in the right direction. We have another question here. With that in mind, what are your thoughts on the concept of single source of truth? This question is from Michael White at Siemens.
Single source of truth?
So can you elaborate on that a bit? Or?
Michael, if you want to elaborate a little bit, we'll move on to the next question.
I can answer that a little bit. So single source of truth from a municipality standpoint is, and Jim touched on this, each agency is responsible for their data. So, the sensors that are in Cary that we provide that data in, we are the central source of truth for Cary. Same as Raleigh, same as Wake County. The state, pulls that data in, but in areas that maybe falls in their jurisdiction, they're the single point of truth. But I would say from this regional effort, each entity is the single point of truth for their data. And in that light, we would be sharing based on our agreements that we agreed on what type of data we're going to share.
Thanks so much, Terry. We have another question here. With the regional data sharing project, is there an AI element that is being used in real time, or is it being monitored by people at specific intervals?
We could, Terry, do you want to talk a little bit about what you're doing at Cary with respect to that?
Yeah, so I would say from a regional aspect, we are just trying to share the data right now. I think in one component I didn't mention, we were gonna when we were starting to build this in the Cary environment, we had these grand visions that we're gonna put AI in, we're gonna automate work orders, the data's gonna come in, and we're gonna issue automatic work tickets when this water gets to a certain level. And I will say that it takes you when you're working with the subject matter experts and the staff that are responding to these things, you got to take a baby step, and you really got to get them accustomed to the data and make sure that data is spot on right. So we actually pulled back a bit, and we said, when the data comes in, we set up in Salesforce, we set up a model so that, as Jim mentioned, when it hits a certain level, it'll automatically send a trigger for folks to start monitoring the water. So you don't have to sit there and watch a dashboard and all that. It'll start sending messages when a threshold has been reached. But issuing a work order, we want the user for a while to get accustomed that the data is correct. And then we get into, let's start looking at automation, AI, and how that works. So that's one piece of it. And then I say the second piece is, we're working with SAS on the Cary side to bring in AccuWeather data so that we can see, hey, you've got a cell coming towards Cary. It's an hour away. It's estimated to produce this much rain based on the information we have that we've collected over, the last 6 months or a year. Pair that up together, and say we have a probability that at this time, we will need to issue a work order to go out and block off a street. So, that's my 2 cents on it, Jim. If you want to add anything to that.
Yeah, because to build on what Terry was saying is, we had these grand visions early on when we started the working group, but we did realize that this really should be a phased approach. And it's great that we think of predictive models and AI, but it does take time and effort to be able to pull those in. And those models and that, any kind of machine learning AI is only as good as the data that's coming in. So the key is to be able to get that data and get it right and make sure it's accurate. Internally at Greenstream, we call it RAD. We want it reliable, we want it accurate, we want it durable. And so one thing also to keep in mind is, it may not be obvious when you look at it, but up to this point, with respect to water levels and flooding, there is no invisibility. We've heard this from Carrie. We know it's flooding when we get a 911 call. So putting a system in place like this and just being able to capture that data in real time and alerting someone that we're hitting these thresholds is a very big step on this process. So not discounting anything related to the machine learning, and it's something that I'm kind of excited about seeing in the future. But right now, you need that foundation to be able to build on that.
Aren't you the one who always says crawl, walk, run?
Crawl, walk, run. So we're crawling right now.
Well, and I will say, the sensors that we have deployed have some type of edge AI learning within them to know that it may not be just a rain event that causes a water level rise. You might have a broken water main that starts bringing water into the watershed. You may have somebody dumping water into the watershed without rain. And so the sensors have the ability to pick that change up and start reporting faster their information. So, that's kind of a form of AI as well, too, I feel.
Thanks so much, y'all. I have one last question here that I'm seeing. Should or could water level sensors tie into an emergency alert system in the event of a flash flood?
Yes, short answer. That is the goal. And that really is with the respect, when we talk about real time, for example, we're doing this for all our customers and Carrie as well, but Carrie's kind of going a little bit beyond this, is we're monitoring every 6 minutes and reporting every 6 minutes. Previous systems, historically, those systems would gather data and maybe report every hour. So you don't get to see that flash flood. They weren't able to report a flash flood. By being able to do a real-time system, we're able to see those flash events, which is a big, huge step. But that is the downstream. It's not only predictive models, but probably the next big step would be this notification. Terry talked about sending data into Workforce to be able to generate work order tickets. That's part of it. We're notifying those public works guys that need to go out there and take some action because we got a flood event on the roadway. But eventually, midterm, that data gets bubbled up so it can even be pushed out to the public as well.
Yeah, and just to add on to that, an important concept that we try to model and carry that I think is very important for municipalities and others to think about is we don't want to create an app or something that is not something that folks use every day. Meaning that, oftentimes people have app overload, citizen notification overload. I created this app so you can be notified. Well, so does Raleigh, so does Wake County, so does the state. Like, if we can get the data formatted right, share that out to platforms like Waze. Think about traffic. We send data out to Waze because people use Waze much more from a global standpoint. So if I leave here and go to Wilson for the weekend, a Carry app doesn't do you any good. I want a Wilson app. So if I use an app or an alert notification system that is global, and maybe it's AccuWeather, maybe it's something like that, that is such a benefit because then the user doesn't have to download any kind of other kind of notification system. So I think that's an important element around notification that people need to think about.
Yeah, and that's a good point. Is you're not, you know, so flood events are not something that happens every day, and if it's not happening every day, it's not that common to you. And so having a third-party app like that, now all of a sudden you're not familiar with how to use it, and there's enough gaps in between that maybe you don't remember how you used it. So it's important to kind of minimize that, you know, and to look at these global apps, just like Terry said.
There's one more question here, about cellular and LoRaWAN and 5 to 60 second sample rate.
Yeah, so like in the case of Carrie, we are looking at, they're using cellular service. And we could do faster sample rates. The devices have the capability. There's always trade-offs in that. And that's part of where the edge computing and that Terry alluded to. Sure, you can transfer every 5 to 60 seconds, but of course you're burning power as well. And so it's trade-offs. Do we go with larger power, bigger panels, bigger batteries so that we can report faster? Also, flood events don't occur every day. So does it make sense to report that the water level is 0 every 60 seconds, right? Because one of the things that is being done in Cary, and we're providing the sensors, is this idea of, can we slow things down and speed things up when we need them, right? When we see these thresholds being hit, so that we can minimize and reduce the size of the devices. So yes, there's trade-offs in that. Is it doable? Yes. Do you want to do it? You know, maybe, maybe not.
Thanks so much, y'all. Any closing remarks, Karen, Jim, or Terry?
Well, I do want to thank everyone who has joined us, and we hope that you'll reach out to us. I realize that we haven't put our emails up here, so I'm going to put mine. If you have any questions about GreenStream or what we're doing, feel free to shoot me an email or go to our website, www.greenstream.com, and we'll be happy to get to know you.
And I second that. I appreciate being able to talk today, and I'll put my email out there as well.
Thanks so much, all. You can always reach out to me, Caroline@riot.org, and I can connect you to Karen, Jim, or Terry. Thanks so much for everybody for being here. I hope you guys have a great day. Thanks, Karen, Jim, Terry.
Thanks, everyone. Have a good afternoon.
See you guys.